Okay, so today we're going to talk about Module 3, Lesson 4. This is on adding and subtracting unlike fractions. And if you remember, unlike fractions are fractions that have different denominators. And this is going to be a more complicated process than it was when we did like fractions in the last lesson. Before we get too far into it, we need to start by talking about a few terms and strategies that we're going to need for this. So the first thing we're going to talk about is the thing called the least common denominator. Okay, very, very common for us to call this the LCD. You're going to hear that abbreviation fairly often. I'm going to say it, and you'll hear it in your future classes as well. So what the least common denominator is, it's the smallest number that all of our denominator values can divide into evenly. So if you're looking at fractions like 1/2 and 2/5, and you're asked to find the LCD, okay, what you're going to look for is the smallest number that both 2 and 5 will go into evenly. And there's a few different approaches for how you can find this number. You can use prime factorization. That's what your book does. I don't think it's necessary for most of the fractions that we're going to be dealing with here. What I like to do instead is find the bigger denominator. So I'm going to pick this 5 value, and then I'm just going to multiply 5 by numbers until I find something that the other denominator goes into evenly. So 5 times 1 is 5, 2 doesn't go into 5. 5 times 2 is 10, 2 goes into 10, there it is. That's my LCD. And this is going to, as long as I can go in through all of the possibilities, that first one that shows up in the list is going to be the LCD. It's going to be the one that I want. You do want to be a little careful here because there are other common denominators, like if you think about the number 20, for example. Well, 5 times 4 is 20, and 2 times 10 is 20, so this is a common denominator, right? But the least common denominator, that L, stands for least. We want the smallest value that we can pick, so we don't want this one. We want the 10 instead, and using that least common denominator is going to get you to the answer that you want in the least amount of steps, so that's pretty important. Okay, so why do we care about this? Well, we care about this because it's going to let us add these unlike fractions. Let's look at those same values. Let's look at the 1/2 and the 2/5, but this time let's add them together, okay? And doing this LCD thing is going to be a part of the process that we're going to use here. So the first step to add fractions like this is to find my least common denominator. And just like I did in the last one, I'm going to start with the 5. 5 times 1 is 5. 5 times 2 is 10. 2 goes into 10. That is my LCD. And then what I'm going to do next is I'm going to take this problem and I'm going to rewrite it with new fractions that have that LCD value on the bottom. Okay, and because of the way that the LCD works, I'm going to be able to do this for every fraction in my problem as long as I've chosen my LCD correctly. Okay, and we talked a little bit about how to find equivalent fractions in the last lesson. That's going to be my next step. If I look at this 2, I want to ask myself 2 times what gets me to this 10 value. So this is going to be a 5 here, and whatever I do on the bottom, I've got to do the same thing to the top. So 1 times 5 is going to be my new numerator, 5, and I've made an equivalent fraction that has that LCD value on the bottom. That's what we're trying to do here. Over here on the second fraction, ask myself 5 times what gives me 10. What do I need to multiply by here? So that's going to be a 2, right? And if I do it on the bottom, to make an equivalent fraction, I have to do the same thing on the top. So 2 times 2 is 4. Okay, and now that I've rewritten this problem, now my fractions are like, and I can do it just like I did in lesson 3. Right? I add the top, so 5 plus 4 is 9, and I keep the bottom the same. Don't forget, this one is in lowest terms, but there's no guarantee that they will be, so you do want to take a second to make sure that your fractions can't be reduced. Look for anything that goes into the top and bottom evenly, and see what you can do from there. Okay, so let's do another one. Okay, so let's say we have something like 1/8 minus 3/10. Okay, our first step here is going to be to find the LCD. And for me, the strategy that I'm going to recommend is just take the big one. So in this case, the 10, multiply it until you find something that the small one will go into evenly. So 10 times 1 is 10, doesn't work. 10 times 2 is 20, 8 doesn't go into 20. 10 times 3 is 30, 8 doesn't go into 30. 10 times 4 is 40. 8 times 5 is 40, so it goes in there, and there's my LCD. Okay, so again, I think this is the easiest way to find the LCD when you're dealing with numbers that are not too hard to work with, like we will be focusing on for this class. Okay, so my LCD is 40, and now I'm going to rewrite my problem as a new problem with those 40s on the bottom. Okay, so here in this first one, I want to change this 8 into a 40. I got to multiply it by 5, right? And if I do it there, I've got to do it up here as well. So 1 times 5 is 5. Okay. On this second one, we want to change this 10 into a 40. So we want to ask ourselves, what do we have to do to that 10 to make it into a 40? We have to multiply it by 4, right? And if you do it to the bottom, you want to keep your fractions equivalent. You got to do the same thing on the top. 3 times 4 is 12. Okay, and so now I've made this into a problem that's just like the problems that we did in Module 3, right? We've got the like fractions now, so I can change this to, adding the opposite, and I can do my math. So 5 plus negative 12 on the top, my signs are different. I'm going to subtract, so 12 minus 5 is 7, and then take the sign of the larger number. So since 12 is my larger number and it's negative, negative 7 up top, and then 40 comes on across on the bottom. Again, can't stress this enough. This one is in lowest terms, but there is no guarantee that your fraction will be in lowest terms. So you do need to take a second at the end of every single one of these problems to figure out whether this thing can be reduced down to lowest terms. Okay, so let's do another one. Say we start with 3 fractions now. So negative 2/5 plus 1/3 minus 7/10. Okay, if I want to add or subtract these unlike fractions, my first step is to find my LCD. Okay, and when you're finding the LCD for 3 numbers like this, I'm still going to take the same approach. I'm just going to find the big one. So I'm going to start with this 10, and I'm going to multiply the 10 by numbers until I find something that all of my fractions go into evenly. So 10 times 1 is 10. 5 goes into 10, but 3 does not. So I don't want to stop there. I want to keep going. 10 times 2 is 20. 5 goes into 20, but 3 does not. So 10 times 3 is 30. And 5 goes into 36 times. 3 goes into 30 10 times. So 30 is going to be my LCD. Okay, so that's the process that I would recommend for that. Next, we're going to take our fractions and we're going to rewrite them with that LCD value on the bottom. Okay, so over here, we look at this first fraction. We've got the 5. We want to multiply by something to make it into a 30. It's got to be a 6. And then if we do that to the bottom, we have to do the same thing to the top. So negative 2 times 6 gives us negative 12 up top here. In the middle, 3 times 10 gives us 30. And whatever we do to the bottom, we've got to do to the top as well to keep our fractions equivalent. So 1 times 10 is 10. Over here on the last one, 10 times 3 gives us 30. And if we do it to the bottom, we've got to do the same thing to the top. So 7 times 3 is 21 up top there. And now all of our fractions are like. And again, this is just like what we did in lesson 3. Okay, I'm going to think of this as adding the opposite. And then I'm just going to, work my way across the top. So negative 12 plus 10 is negative 2, right? Subtract, take the sign of the bigger number. And then my signs are the same, so I'm going to add and keep the sign. And again, we've gotten a little lucky with these that all of them are in lowest terms. But again, when you're adding and subtracting fractions like this, there is no guarantee of that. You do need to get in the habit of checking every single one of these to see if there's anything in common that can be reduced out of the top and bottom of your fractions. Okay. We can also use this process to compare fractions of different sizes. If you look at something like 3/4 and let's go with 9/14, for example. If we're trying to decide which of these fractions is bigger, it's very difficult just by looking at the fractions, right? Which one of these is bigger? I don't really know, but what I can do to make this a fair comparison, an easier thing to make a decision on, is I can make these fractions into common fractions with the denominator equal to the LCD. So my first step here is going to be to find the LCD. And this one's a little trickier. Again, we're going to take the same approach. We're going to take the big one here, and we're going to multiply it by stuff until we find something that the smaller one will go into evenly. So 14 times 1 is 14. That doesn't work. 14 times 2 is 28, and 4 times 7 is 28, right? So I'm going to use that as my LCD here. Okay, so next I want to change my fractions into new fractions with that 28 on the bottom. So you want to ask yourself, well, what do you have to do to this 4 to make it into a 28? You got to multiply by 7, right? And then whatever you do on the bottom, you got to do the same thing on the top as well. So 3 times 7 is 21. Over here, we want to change this 14 into 28, so we got to multiply by 2 to make that happen. Whatever we do on the bottom, we've got to do the same thing to the top as well. So 9 times 2 is 18. And so now that our denominators are the same, we can just look at the top to decide which of these fractions is bigger. So 21 is bigger than 18, so 21 over 28 is greater than 18 over 28, right? When our fractions are unlike, it's very difficult to look at them and decide which one is bigger, but when we get it rewritten so that our fractions are like, then we can make a good comparison that way. Okay, so you'll also have a few questions like this in your homework where it asks you to do an addition like this, but it might not ask you to do just the addition. Like this one says, we're going to actually do this problem a couple of different ways. The first thing we're going to do is we're going to kind of estimate the answer, because sometimes when you're doing math, you don't need an exact value, you just need a ballpark kind of value here, and much easier to do that way. So we're going to do that first, and then we'll find the exact value after that. So if we want to do an estimate, what we want to do here is we want to look at this top number of our fraction, and we want to ask ourselves, okay, is this half or more of our bottom number? And the answer in this case is it is more than half, right? So we're going to round this up. So 2 3/4 is about equal to 3. Okay, and then if I look at my bottom one, the same thing. Now I've got this 1 up top, and that is not half or more of my bottom number. So I'm going to leave this one the same. So if I just want to do an estimate, I'm just going to round the values off based on whether that numerator is half or more of my denominator, and then just kind of do the math from there. So this is about equal to 6, okay? So that would be an estimate, a way to do this approximately. If I wanted to do the exact value, though, it's more difficult. We're going to have to do a little bit more work. So if I want to find the exact value, the first thing I'm going to do is I'm going to change my mixed numbers into improper fractions. You remember we've learned this before. We're going to multiply here and then add here. So 4 times 2 is 8. 8 plus 3 is 11. Over 4, and then down here same thing, we're going to multiply there and then add there. So 8 times 3 is 24, plus the 1 up top is 25 over 8. And then my next step is, because these fractions are not like, to find an LCD. So my LCD here, again, I'm going to take my same approach. I'm going to take my big one. I'm going to multiply it by things until I find something that the small one will go into. Don't have to go very far. 8 times 1 is 8. 4 goes into 8. Don't skip that one. It's a very common mistake for people to start. 8 times 2 is 16. 4 goes into 16. Use 16 for your LCD. Don't make that mistake, because you're just going to make the problem much more complicated and make your reducing more involved. So you don't want to do that. So 8 is going to be our LCD. So I'm going to rewrite these fractions as new fractions with that 8 on the bottom. So 4 times 2 gives me 8. Whatever I do to the bottom, I've got to do the same thing to the top. Okay, down here, don't have to do anything. So I'm just going to multiply by 1. Okay, and I've made my fractions into like fractions, and now I can add 22 plus 25 is 47. Okay, and then looking at the bottom, I'm just going to bring it on down. And I do want to take a second to see if this can be reduced down to lowest terms. But again, this one is already there. Okay, so 47 over 8 is our answer. And you do want to read your instructions here. Like, this is okay. This is a correct answer to this problem, but it's an improper fraction. The instructions for problems like this, though, will probably ask you for a mixed number instead. So we do need to convert this on back. If we want to do this as a mixed number, we're just going to divide the top by the bottom. Okay. So 8 goes into 47 5 times. 5 times 8 is 40. We're just doing our improper fraction to mixed number conversion like we've done in the past. And so 5 is our whole number, 7 our remainder goes on top, and then our denominator stays the same. So 5 and 7/8 is our answer as a mixed number. But if it doesn't ask you for a specific form, I would take either one of these. But in this particular problem, it does specifically ask for a mixed number. So this is the answer you'll want to go with for MyMathLab. Okay, so hopefully that's enough to get you off to a good start there. Please let me know if you have any questions.